Gardner Harold wants to construct a 600 square foot rectangular enclosure that has a vertical partition. What dimensions will require the minimum amount of fencing, and how much fence would that be? So let's make a sketch of the enclosure. It's a rectangle. Let's pretend that's a rectangle, and it has a partition, which in our picture will make the partition vertical. The variables will be x for the length and y for the width of the rectangle. The area is the area is x times y, and the amount of fence that's needed in this construction is 2x plus 3y. Now in the problem it says that the construction must be 600 square feet, so that means our area must be 600 square feet, so x times y must equal 600 square feet. That will be our constraint. And we are trying to minimize the amount of fencing, so we would want to minimize f subject to xy equals 600. Okay, so we take the constraint and we solve it for y. So the constraint says that y is equal to 600 divided by x, and then we substitute that into the objective. So the objective becomes f equals 2x plus 3 times 600 over x. And we can write that as 2x plus 1800 over x. So that's our objective. That's the amount of fence needed to create this enclosure having 600 square feet. So now we calculate the derivative, and we'll notice that x must be positive. X and y are at least 0, and since their product is positive, x is definitely positive. F prime is 2 plus, and here we need the derivative of 1800 over x. 1800 over x is the same as 1800 times x to the power minus 1. So then to calculate the derivative of that, we will use the power rule. We will get negative 1 times 1800, x to the power negative 2, and that is negative 1800 over x squared. And we're looking for critical numbers, so we should let this equal 0. So that means that 1800 over x squared, if I move that to the other side, is equal to 2. So 2x squared is equal to 1800. X squared is equal to 900. And so x is equal to plus or minus 30 feet. And x in this situation has to be positive. So x is 30 feet. And let's double check that that gives us a minimum. Let's calculate the second derivative and use the second derivative test. So the second derivative, the derivative of 2 is 0, and the derivative of negative 1800 over x squared, well, negative 1800 over x squared, doing the same thing we did here, is the same as negative 1800 times x to the negative 2. And then the derivative of that is the negatives cancel. We get 3600 x to the power, subtract 1, negative 3, or 3600 over x cubed. So 3600 over x cubed. And so that means that f double prime at our critical number 30 is 1800 over 30 cubed, and that's a positive number divided by a positive number, so that's positive. And a positive second derivative means that we're talking about concave up, and combining that with a critical number, we do have a minimum. So the minimum amount of fencing will happen when X is 30 feet, and then Y was equal to 600 over X, so Y is equal to 600 over 30, which is 20 feet. And the total amount of fence that is needed is 2X plus 3Y, and that's 2 times 30 plus 3 times 20, and that's 120 feet of fence.